Bearings. So what do you think bearings is?
It's like it's a three. Sorry, how about this? It's like three digits. It's given in the form of 3 digits, and it's in degrees. So it's kind of like how many degrees is not traveled, but like I don't know how to explain it.
It's
It's
okay.
just like that. That.
So let's say we have like you're placed at this point and I'm placed at this point. Okay. So for bearings, what you do is, let's say Jasmine is over here, Mariam is over here. So first what we do is we draw the axis on those two specific points. Okay.
Okay.
So that's our axis. So now if we connect the two dots, so this is the distance between us, right?
Yep.
Now coming to the angle, if they're asking you to find the bearing of J from M. So the bearing of J from M, so what we do is we start from M and we stop at this point where the line appears, okay? So this is the position of J from M. So when we're starting from the north of M and going to the line, so this is the bearing, okay? Now let's say this angle they've given us as 30. So if you remember the alternate angle properties, so if this is 30, this alternate angle is also 30, right?
Yep.
So an angle of a straight line is 180. So the bearing of J from M would be 30 plus 180, which equals to 210 degrees.
Wait, how?
How? Because
30 plus.
we added it. Because it's from north to this line.
Yeah.
So one angle we have is 180 and the other is 30.
Okay.
Yeah. Now if they were asking for the bearing of M from J. Now in that case, we have to find this bearing. So that's 30, which is already given.
Yeah. Because it goes clockwise, right?
That's right, it goes clockwise. And it always begins from the north.
Okay.
So is this clear?
Yeah.
Okay, I'll give you a question. So let's say we have this is point A, this is point B. Now these 2 points are connected by this line. And let's say this angle over here is 20 degrees and this over here is 70 degrees. This is 70. Okay. So now your question is that first part is you have to find the bearing of A from B, and then part B is the opposite. We have to find the bearing of B from A.
Okay. A from B is 200 degrees.
A from B. How did you get that?
Because alternate angles means that the one underneath would be 20, and like that is a right angle as well. And then okay, wait. I think I need to add another 160
160?
of a straight line, right? Like
So
160 to reach line.
basically, we're going from the north,
I need
and
to add another
we have to add a 90. Yeah. So it would be
90
for A, it would be 180 plus
plus 90.
90 plus 20. Basically, that's 270 plus 20. That's 290. Then what about part B?
It would be. Wouldn't it be 110?
How 110?
Because that's a wait. Is that a 90-degree angle there?
Over here, yeah, it's one quadrant, so one
Yeah.
quadrant is always 90. So 90 plus 20 is 10. 110. Do you get the concept behind this?
Yeah.
Sure.
The thing that I was
Hmm.
is the wording of the question, but then when you drew those like those axes
Hmm.
on the point, now I understand. But before, like when it said bearing of A from B,
Yeah.
like I thought I was calculating, like I didn't know what to calculate. Like I
That's
was
the thing.
confused.
Yeah, I get the issue because you'd always need to draw the axis because without the axis, obviously you can't figure out, what they're asking for. So you get confused with all the angles given in the question. So always and always draw the axis on the points that they've given to you, okay? Okay. So we have 70 and 110. So first step, let's draw the axis. Let's use a different color for that. So that is one, that is the other. So keeping this in mind, what is the bearing of B from A?
Of B from. So like should I calculate it now?
Yeah, I'll try to do this.
It would just so the straight line is 180 and the
Mhm.
alternate angle is so 250.
That's right. 180 plus 70 equals 2. It's clear more, right? With the axis.
Yeah. Yeah, definitely.
They are not written the questions properly. What? I don't. 57. Okay, so this is the angles. So A to B now they have given this 57 angle from somewhere, and then you draw the axis. So corresponding angles are equal. So if this is 57 at A, it will be 57 outside of B, like if you go clockwise. So basically, in our case, if this is 70, this would be 70 as well.
Okay.
So this goes back to the corresponding angles are equal. Okay, so can you try to solve this question?
So when it says A to B,
Hmm.
so it's the angle of B from A, right?
Yeah.
Okay. Miss, I'm still like, I'm just a bit confused
About what?
about B. When it's saying like C from B,
It's
because like I finding it hard to draw the thing because of so much information on this.
okay.
Okay.
So let's start from part A. Part A is beating from A to B. So it's going to be the beating of B from A. So we draw the axis first. So beating of A from A to B. So
It's
that
given, right?
the beating from A to B. So that's the beating of, find the beating of B. That's the beating from A to B. It's going to be from A. So it's going to be this part. This is 65. So A is going to be 180 plus 65.
Mm.
Okay.
Yeah.
Then bearing of B just from B to C. So that's going to be this part. So this is 65. This whole is 87. This is going to be, first you find that angle, so that's 180 minus 87, which equals to what?
90. Sorry. Yeah, 90.
Can't be 90. 93.
Yeah.
Then 93 minus 65 will give us the angle in the middle.
28.
That's right. So now 28 is over here. So alternate angles, if this is 28, this is 28, right? So then 360 minus 28 equals to
300.
352. Okay?
Yeah.
Repeating from C to A. So that would be this one. So that is 65. We do first 180 minus 93 minus 56. That is 31. Then we do 31 plus 65.
Wait, Miss, how did you get 90?
How did I get what?
93 and 56.
So
Like, where did it?
180 minus 87 over here on this line at point B. When I did that, I got 93. Then 56 is given in the angles. Look this at C.
Okay.
So
And then you're calculating the
Hmm,
triangle.
that's right. So for part C, it's 96. So today we begin with functions. Now, what do you know about functions? Like, what comes to your mind when you think about functions?
Fx equals to
Hmm.
like inverse functions. That's what I think of first.
X equals to something and inverse functions. These two things?
Yeah.
Okay.
Yep.
So that is somewhat like, right? But
Big.
yeah, a little bit. It's like an advanced definition, but like there needs to be some, ABCD attached
Yeah.
to it. So functions is basically your mapping. We are mapping points in functions. Yeah. Now, let's say I write this equation, y equals to 2x minus 3. Now, in this equation, we have one variable, which is y, and the second variable, which is x. Now, y is said to be the same as f of x. And these two denote the domain of your function. Wait, that's the range of the function. That's the range of your function. X is your domain. Now, easier words for domain and range is domain is your input, range is your output. Okay?
Okay.
Basically, just consider the function as a machine. You're putting input raw materials into it and it's coming out with like refined products. That's your output, which is your range. That's what like basic, think about functions.
Yeah.
So let's move to function is point. And now with functions, we have, if we draw all possible vertical lines on a graph of relation to function, the function of each line cuts the graph no more than once, is not a function if at least one line cuts the graph more than once. So now by this they mean, if we draw a graph over here, so if it's cutting the line by line the axis no more than once, the graph, it is a relation. It is not a function if at least one line cuts the graph more than once. So if it's cutting more than once, it's not a function. If it's cutting just once, it is a function. Now this is basically a one-to-one function thing. That one value of x will produce one value of y. Like if it's 1, 0 over here, that function only have this point. That's it. We can't have another 1, 0. That's what a one-to-one function means. Okay?
Okay.
So now which one do you think is a function in this case?
Y, I mean A and B.
A and C. A and C are functions. B is cutting the graph at more than one point.
But C is
C is not a
cutting
function.
like
Yeah.
twice in like one
Oh
line.
yeah, that line. There's a line over here.
Yeah.
So yeah, A is a function, B is a function, C is not a function. Now, moving on to another basic point. If a graph contains a small open circle, such as this blank dot, this point is not included. If it's the colored dot, that means the point is included. If the graph contains an arrowhead at an end, such as this, then the graph continues indefinitely in that general direction, or the shape may repeat as it has done previously. So if you look at these functions once again, these blank dots represent that the graph does not contain that point. And the arrows show that, okay, so in the case of A, it's going towards negative x infinity and positive as well. And that is the case for B as well, but in C, it's just going towards positive infinity. Okay?
Okay.
So now, which of the following sets of ordered pairs are function? Okay. So let's draw the axis first. This is our axis. And now they're asking us to give an equation proof that will a straight line always be a function or not. So let's say I draw this straight line.
Okay.
Let's assume this is placed at 4. So this is y equals to 4. Is this a function?
Yes,
How?
because it doesn't cross the line more than one time.
It doesn't, but the thing is, a function is supposed to be a relation. So right now, this equation is only y equals to 4. There's no relation going on in this case. It's not connected to another variable. It's just one point, y equals to 4. For us to have a function, it has to be like y equals to 2x plus something, for example, 3, or, x squared plus, something like that. You get it?
Yeah.
If it was x equals to 2, this would also not be a function. So in order for
Yeah, I
us
get
to
it
have
now.
a function, it has to be a relationship on that straight line as well. Okay?
Mm.
So in functions, another type of question that we can get is fx equals to, let's say, 2x squared minus 3x. And they want us to find, if fx is 2x squared minus 6, find the value of f of 5 and f of 5 minus 4. So with f of 5, what we do is, we replace x with 5. So 2 times 5 squared minus 3 times 5, which is 50 minus 15, which gives us 35. So how would we do f of negative 4?
Okay.
How will you solve f of negative 4, number?
So first we do f brackets minus 4 equals to 2 minus 4 in brackets squared minus 3 minus 4 in brackets.
Okay. So 2 times negative 4 squared equals to?
4.
32. 4 squared is 16. Times 2 is 32. Plus 12, which
Yeah.
is 44. So that's your value of the function when we put x equals to negative 4.